1, go. Good day to you all. On behalf of Cenosco, it is my pleasure to welcome you to our live session about asset integrity management. Today is quite special. I can announce already that there's our record audience with the two special guests. Well, my name is Luis Corrado. I'm a solution engineering and business development manager here at Cenosco. And today, rather than be talking too much, I'll be the facilitators on today's session. Today, we're going to explore the true impact of artificial intelligence in asset integrity management. Let me first introduce my guests. We have invited two industry experts who will discuss these insights. So Dan Jevons and Josip Haravatin, our dear Pepe, how we call it. Dan is the Vice President for Computational Science and Digital Innovation at Shell, and he has been instrumental in shaping Shell's digitalization program and played a key role in developing the externally recognized Shell.ai brand. Pepe is our director of software engineering at Cenosco, although I wanted to bring him to sales. His leadership has been pivotal in shaping Cenosco's software engineering initiatives, contributing to continuous advances in the field. So before we start, I think it's good to explain the framework of our discussions. We're going to first start by looking at the artificial intelligence journey, how we came to be where we are today. Then we're going to discuss artificial intelligence on our, as I call it, in our asset integrity world. We're going to talk a little about the Open AI Energy Initiative that Cenosco and Shell are part of. Lastly, we're going to look ahead at the future of AI in asset integrity management. At the end, we will have some time to answer questions. We have received already many nice questions up front, and I thank you guys for that. But feel free to put any additional questions you might have in the chat. We might not have time to answer all the questions, but we will get in contact with the audience and answer those questions separately. Technicality. So if you have, for any reason, you experience a bad connection on our side, a refresh of your browser will bring you back to the webinar. Let's get started then. Hey, Dan, it's really an honor to have you here. How are you today?
Yeah, very well, thank you. Thank you so much for the invitation. It's great to be with you.
Thank you. Good to see you again, my dear Pepe. How are you doing?
Hi, Luis. I'm doing good, and I'm really glad to be here today.
Good. Finally, we managed to drag you into one of these sessions.
Yeah.
Let's first talk about the AI journey, right? Let's first rewind a bit into the past and talk about the AI journey. How did we get to where we are today? I've read that artificial intelligence was already founded as an academic discipline back in 1956. And Pepe, you also mentioned to me that you already encountered AI at the very early stage in your career. Can you tell us a little bit more about that journey in terms of software engineering and AI?
Yeah, Luis. Something that today we call AI, I encountered during my university ages back then in 90s, together with my roommate and my colleague who studied pharmacy. We started building one algorithm or something that can, based on the database of symptoms, make some diagnosis of the disease. So back then, the data was very limited because the only input that we had was based on the books and some articles. So you can understand that there is very limited amount of data and not enough to build a real or something real usable in context of machine learning. But it was the first step. Back then, you can, if you put this in a time frame, this is the time when the Deep Blue was promoted, or the first artificial intelligence who beat uh, uh, the chess championship, or he beat the Kasparov several times, was built, and they you can check this on internet. So they as input used thousands and thousands of games. So they managed to build a significant machine learning model, but for that purpose they needed really a special machine. So back then there was a lot of limitations in infrastructure, in data quantity, but also the data storage. So it was a simple model, what we did. But later, during my professional career, I was also engaged in creating a robot who was uh, taking care about one warehouse. It was fully automated warehouse. And besides getting the pallets and delivering, this robot was also rearranging the whole warehouse during the night. And the inputs for rearranging that warehouse was provided by the sales data and based on the historical way of creating the delivery packages. So it was again a small machine learning model, but we are talking about decades ago.
Yeah, I was not going to touch that point. I was not going to disclose how long ago was it, but that's okay. If you call a couple of decades ago, give us an idea. So many of these algorithms behind AI and machine learning are indeed not new, right? Um, like you said, Pepe. But especially the fact that data was limited and inaccessible has hampered that application. So without the data, the AI could not work, and there where digitalization comes in. Then, so Shell has been really a true pioneer in development and deployment of such digital technologies for many decades already. So I read that Shell has over 100 artificial intelligence applications in various stages of the development and deployment across multiple business. Can you take us back to where it all started and how Shell was able to reach that point?
Yeah, for sure. I think, firstly, let me start by saying I think we're all on a journey here, right? So I want to start by acknowledging, in all humility, that I think we're all learning about this space. I think, as Pepe's pointed out, some of this has been around for a very long time. A lot of these algorithms aren't new, but the data volumes and the compute capabilities have transformed the art of the possible, and also have sparked a level of innovation that I think few of us have ever seen, and I think will have a transformative impact on society in the years to come. And I think the pace of change in AI is extraordinary. So I think whilst the core concepts are well understood, I think the pace of innovation is impressive, and is something that we all need to approach with humility, recognizing we've all got a lot to learn. So hopefully we can learn from each other during this short conversation. I think that the second thing I want to say is that within Shell, I'm very fortunate in that I build on a history of leadership in this space. That goes back to the scenario modeling capabilities that were built, really is one of the earliest strategic concepts that Shell developed, and of course something that still goes on to this day. We developed a world-leading statistics capability in the 1970s. So in that sense, data science, just as Pepe said, is not new. Many of these core algorithms have been around for a very long time. That said, I think what is new is, as I mentioned, the scale of data, the scale of compute, and the way in which these algorithms are being deployed into production as part of software applications. And I think that has really changed dramatically in the last few years. I think also to build on that and to talk a little bit about our story and my story, I think the awareness that there was something happening in this space goes back about 10 years. And I was asked at that time by my line manager to develop something which we then called the Advanced Analytics Center of Excellence. I like to say it was none of the above, i.e. it was not advanced nor a center nor excellent at that time.
You have an acronym for that?
So we were very much trying to figure out what this technology meant and what it could do. But I think what that what has happened as a result of that is we were, I guess, a little bit ahead of the curve. So we were able to start developing a capability around what we would now call AI, which is really the emergence of some of the technologies that we're going to talk about today. And indeed, we've come quite a long way on that journey. To put that in perspective, as you mentioned, we've got north of 100 AI applications in production. We've got over 600 people who would call themselves professional data scientists in the company. We've got over 12,000 people as part of the Shell.ai network, which is the network that we use to manage change and the embedment of AI across Shell. So that just gives you a few of the outline statistics. So we have reached an impressive scale. We're also, publishing papers and really kind of pushing the envelope in terms of what's possible in our industry. Of course, we're partnering with many companies, yourselves included, on this journey, and we'll talk more about that. But I guess just to close out, I think I still want to say we've got a long way to go. This is an emergent field. It's a fast-moving field. There's a huge amount to learn, and I think we're only just getting started with the potential of the technology in terms of the impact that it can have across major corporations like Shell.
Nice. Thank you, Dan. Now let's talk about a bit more into the how AI impact and is used in our asset integrity world, right? Asset integrity. I'm talking here about all the mechanical integrity, safety instrumentation, reliability, flange management, pipeline integrity, and so on. And I really like this quote from Shell's website that says, "Digital transformation marks a radical rethinking of an organization that touches all processes, people, technology to fundamentally enhance the business performance." I think it's really nice how he touch pretty much everything in a sentence, right? How that process is enhanced, how that supports the people and the technology that put all together. That's really nice. So I could not resist in talking a little bit more. So I like to bring the to mention the as an opening for the next topic, our digital maturity framework, right? So how do we see that digital maturity and how that impact the use of the technology for many business and many industries? So you probably heard and seen that framework before. What does it say? It says is the more maturity you are on the X, the better you become. On the Y-axis, you say the technical assurance. So you're compliant, right? So you're more reliable, but also you have the best cost optimization. And I'm gonna steal an approach from previous discussions with them. It's like the more mature you are, the less emissions you're gonna have, right? I would squeeze that into like that technical assurance, but it's quite important to highlight that the more digital you become, the more efficient you are, and that's a journey. I like to say that you don't expect to manage your assets in an Excel file, and then overnight you send a request for proposals in the market and say, I want to use AI now. There's a journey, right? So you need to be you can step a couple of steps, you can skip a couple of steps in that journey, but you need to be digitally purposeful. We're going to talk about what do I need, what is the outcome. You need to be integrated. There's no standalone solution. There's not the one solution that will solve all the problems. And then at the end, where we typically put a company like Shell as a digitally strategic, that recognize the importance of that. It has a lot of data. That data is integrated. It has some backlog, and then you can create. You can apply AI, and we're going to cover some of these applications in the next few minutes. So, bring it back to you, then. What role do you see AI playing, or not playing, in the asset integrity world?
Yeah, no, fantastic. And if you'll bear with me, I'll broaden that question a little bit, because I think it's
Nice.
probably pick up where you left off and talk a little bit about how we see it, because I think you put it really well. I mean, you talked about some of the outcomes that we're looking to drive. At the corporate level, it's more value, less emissions, right? That's the key sort of strap line that our CEO talks about. And I think that that's a great rallying call for the organization. And of course, when you deepen that, you have to say, well, what does that mean? And in this space, what does that mean for asset management? And so you start thinking about outcomes. You talked about being digitally purposeful. I think that's exactly it. You need to figure out what is it you want to do with digital technology, because digital is just a tool. It's an enabler to do things differently. Um, One of the things that we've been reflecting on is exactly this, that um, it's not just about implementing the technology, but it's also about embedding it in transformed work processes. In fact, I wrote an article on this in Harvard Business Review uh, with a couple of friends last year, talking about how business process re-engineering is going to be absolutely fundamental as we think about the era of AI. And so, in that context, you have to think through what are the outcomes that you're trying to drive. And for us, it's quite simple, really. We want our assets to be safer. That's always number one. So driving safety is really critical. Similarly, we want to make sure they're more reliable. That has obviously safety implications. It also has cost and production implications, and of course emissions implications too. So safety, reliability, and then we come into optimizing performance, looking and trying to say, how do we debottleneck the process to both produce more and emit less? And then finally, looking at also the integrity aspect of things. How do we continually review the site for integrity issues in a faster, cheaper, more efficient way that allows us also to make the whole process more reliable as well? So a lot of these outcomes you can very quickly come to when you start thinking about what matters for an asset. The more fundamental question is, how do you think through how does digital change the way work gets done today, which is then back to what I was saying about business process re-engineering. And I think the really positive thing is that AI is challenging the paradigms of how traditional work processes are constructed. I think the outcomes remain the same. The processes themselves remain important, but the way in which those processes get executed and the way in which you can potentially combine some of those processes is going to be fundamentally different. For example, if you think about a work process like, for example, predictive maintenance, you can start to think around a world in which almost all maintenance tasks are done on the basis of forward prediction versus corrective action. And I think that whilst the work processes are still going to need to be there to make sure the work gets done properly, the way in which those work processes are triggered is going to be very, very different in the future. And I think this is also where this conversation is so important, because what I really like about this conversation is we're already bringing together folks with experience like yourselves in the asset integrity space, as well as people like myself who spent a lot of time in developing AI solutions. And I think it's that intersection of digital experience with fundamental understanding of the robust work processes that are used today that's essential to rethink the way in which we work.
Guys, thank you. I think it's a very good point. So when you say work process, and I think we're referring more as a high level process, such as the I think you used to call the MEC. Now it's the MAC for managed asset care, and those processes will kind of remain the same, right? So you just have different tasks and different ways of doing that. Yeah,
Exactly.
and those have changed over the years. So, Pepe, how do you see the adherence of these existing process in shaping the AI in our integrity management?
Yeah, so we had this discussion also internally around our AI change the processes or not. So from the high level, no, processes will stay the same, but on some lower level, or the approach will need to change. You just mentioned the MAC or MEC. So before Shell had this MEC approach, so the based on the equipment, and now they're moving to MAC, which is based on asset or the wider information, or how they also called it, and I will use the words from Stefan from the other day. So the fleet approach, so to take care about the equipment based on wider information, or combine the data. So the similar is in IMS. If you focus really on the small amount, or the single piece of equipment, you don't have enough data. But if you make this bigger, larger, then you have more information. This is also what OpenAI initiative brings. But if we talk about the processes, I'm always taking air, one which we'll talk about later more in details, but as an example. So when we tried to just mimic the visual inspection way of working, where the person or the inspector goes outside and inspect one equipment, and if you use artificial intelligence to help that person on the field, this is not adding too much value, because the person is already there and makes the inspection. So to consult artificial intelligence is not the best way of doing things. But when you combine the things and you scan the wider range and take the images of from different angles, from different ranges, then this gives you the value. And we are talking of processing of the big amount of data. So we are always talking about the data. We need big amount of data where the artificial intelligence can help. And because of that, the processes will need to change, because instead of collecting single point of single inspection, we need to extend this on the wider, or to use wider aspect of data. For example, with the increasing of the sensors on the site, will probably decrease the need for some kind of assessments like RBI. So there is also some prediction that RBI in the future will become obsolete if the sites have enough sensors. So this is where I think the processes will need to change or to adapt to the new technology.
Yeah, thank you. Good thoughts. Just adding a bit. I think the AI in the integrity management, it will not replace the inspectors. I don't think for many years will not replace a corrosion engineer or the responsibility of the asset manager, for example, because of the compliance, right? So you still have a lot of compliance. At the end of the day, there should be a person that is responsible for taking a specific decision and using that outcome from AI, right? So I think legislations will take a while to digest AI. I don't think you can put AI in jail, right? If things goes wrong. So I think the compliance part will also play an important role in shaping that direction. But again, I think it will be important. It's already important to increase the level of integrity, increase the reliability, and so on. Then I'm gonna bring back to you. Can you give us some one example on how AI has provided added value in Shell's operation?
For sure. I mean, I think Pepe's already talked about air, and I think we'll talk more about specific integrity examples later on. So I thought I might pick a couple of different ones. One is proactive technical monitoring. We monitor, I think, well north of 19,000 pieces of equipment now, all around the globe, across 23 plus different facilities, using a combination of AI and physics-based methods. That's successfully identifying and preventing reliability issues across our global asset base in advance, and then providing those as insights, actionable insights back to the sites. We run 2 global proactive technical monitoring centers, one in Bangalore and one in the US, in New Orleans. And that's been a fantastic success story, where we've brought together, as I said, AI plus physics-based methods to provide interpretable information back to the sites to identify trips and alerts before they happen. So that's one great example. Another example would be some of the work we've done in optimization. We've seen the ability to use advanced optimization techniques in combination with advanced process control to increase production on LNG trains by as much as 1 to 2%, but also alongside that to reduce the emissions associated with the processes, just by looking at advanced optimization, massive scale of data sets to look at where we can debottleneck or tweak parameters within the engineering envelopes to optimize the overall performance of the asset. So I think there's lots more I could talk about, but those are just a couple of examples off the top of my head that give you a sense of the sorts of things that we've been working on.
Nice. Let's take the opportunity to go into and talk a little bit more about the an initiative that was headed by Shell and has the most important players in that market. So that's exactly what the OpenAI initiative is doing, right? It's searching for AI solutions to tackle difficult problems in the energy industry, right? Like make sure that operations run smooth and improve maintenance. So then I don't want to describe and talk more about the OpenAI because you've been there for long enough. I think you've been fundamental in putting that together, being involved. Can you tell us a little bit more about that initiative?
Yeah, of course. And I think, look, I mean, you have to watch me here because I can get on my hobby horse a little bit because this is something I'm very passionate about. I think, one of the challenges that we've seen in asset management in general is the fact that a lot of the solutions are very siloed. If you go to a typical operating facility today, you'll see a bunch of different technologies, many of which isn't fully integrated. The data is not fully available in all the different packages. And each discipline is operating within effectively a data silo. Within that silo, often the data is very transparent, but across to other related disciplines and related processes, as well as data that's highly relevant to that discipline that is in another silo, those things are not very well integrated. When you start to look at what can AI do, one of the big challenges, how do you create an integrated landscape, going back to where we started, which can allow us to transform the work processes? And so what we've been looking to do is say, how can we enable that? And one of the things that we've come to believe is that you have to think strategically at a higher level around how you build an ecosystem that can together transform the way in which operations happen, which in turn can transform the business processes. And so again, if I just unpack that a little bit, what does that mean? Well, for a start, we believe in open data foundations, open source code for the way in which you manage data, open data standards for the way in which the data is stored in that landscape. Not saying you need to open up all your data, recognize that's probably a bridge too far, but certainly open standards and open source at the core is fundamental because it creates an open data foundation that others can contribute to and that we can align around. And so we've been very aggressive in the way in which we've gone about that. So we have open sourced all of our subsurface platform. OSDU was initially Shell was the SDU originator that then became OSDU when we open sourced it. That's been starting in the subsurface space, but moving into the production space. And then if you look at some of the work we've been doing more recently, we've recently open sourced our foundational time series platform, which is available in the cloud. It's called RTDIP. We open sourced that under Linux Foundation Energy. And we've made these capabilities accessible because we want others to build on top of those open data foundations. So that's the bottom, open data foundations, open source. On top of that, we recognize there's always going to be a place for proprietary software. And the reason why is because when you're running safety critical assets, you want to make sure that what you're deploying is robust and performant, that it's got the right kind of assurance standing behind it, that it's been verified by the regulators, and all of those things require cost and effort. And as a result, we recognize that in many of these safety critical spaces, the software that's involved is really going to need to be provided by a commercial entity. That said, what we don't want is a commercial lock-in and a silo from a Shell perspective, but also, frankly, from a user perspective. What we want is interoperability between different stacks, and also integration with that common data foundation so we can leverage that data for the purposes of AI. So interoperable, modular, integrated is the key to creating those end-to-end workflows. And then again, just on top of that, open at the top. So open APIs, allowing us to plug and play those workflows through simple visual UIs, like, for example, a digital twin technology that allows us to make sure that from a user perspective, you're not dealing with silos, but you're dealing with an integrated whole where the full data set surrounding the asset is available to you. That's really the vision behind OpenAI. And of course, in the middle of that is the fact that in all of these processes, in all of these solutions, we expect AI to be fundamental and embedded. And we see with the emergence of generative AI, which no doubt we'll come back to, that whole process of AI embedding in software is just accelerating. So what we want is AI powered software, AI powered work processes, transforming the way in which the asset operates based on open data, standards, and open source.
Nice, thank you, Dalek. That's quite a good insight there, and it's been quite an interesting journey for Cenosco so far. And when I say interesting, is in a positive way. I think the British might sometimes call it interesting on they take on the other side, but I think it's been very productive. I think we learned a lot. Um, Between giants, I would say, right? So the let's say the founding members there were quite significant larger than Cenosco, but we've been the backbone of that structure, right? So we had the all the asset hierarchy, the historical data. We did had a lot to offer, and that exchange was really amazing. So I've been here with Cenosco for 5 years, so we saw the product growing, yeah, and we since we joined, we actively participate in two of the key, or let's say Pepe would say three key projects. So Pepe, you want to cover a little bit on these on those two, now three projects that we've done as part of the OpenAI.
Yeah, so first one was AIR, which I mentioned before, which stands for Autonomous Integrity Recognition. That was the first project that we did together with Shell, and we started this project. I think it was back in 2018. So the first implementation, like I said before, was not really the best because of the use case, but it was really good for get some learnings and to have some testing, of course. But now what we later did, we call this as Air Observation Project, where we combine as multiple technologies, and this is also always about, so to use the machine learning you need, or to any artificial intelligence, you need to combine with some other technologies to get the right use case. So now it's based on scanning an area and creating 1,000 of images. We talk about 20,000 images, for example, and then based on those 2D images, build the 3D models or the point cloud images, which we then intersect with the 3D model, and immediately we can recognize on which equipment, based on the machine learning or this machine vision artificial intelligence engine, we can recognize where on which equipment there is an issue. And with something that Shell introduced called virtual inspectors, they can do the inspection from the office instead of sending someone into the risky environment. And I think this is really where the artificial intelligence and new technology came to the point, and to really brings a value to the process. So that was the first one, and that's also closest to my heart because we started from the scratch. Then the next one that we did and integrated with IMS is Karma. This is the initiative to resolve the prediction of the corrosion rate with the several types of degradation mechanism using some data historian sources, and so I think at the moment we are where we were with the air phase one. Now we are with Karma in the same spots. It is about to find the right use case, which I think it is coming, and that is with the third project, which is called Ken CUI. Ken CUI stands for Karma, Air, and natural language processing, and CUI stands for corrosion under isolation. So now we are using three type of artificial intelligence to identify the corrosion under insulation. So we are just about to start this project, and I'm really happy that we are combining more and more of these methodologies and making some really cool stuff.
Thank you, Fabio. I think air was it's a good example, and I like when you say use case, right? And I don't hide from anyone that I was a bit of a critic of the first version of air. I'm an inspector. I was an inspector myself, doing a lot of NDT and inspection. Say, why you guys are doing this? There's no value for me. At the beginning, air was automatic image recognition, if I'm not mistaken. So it changed, it upgraded the name. I don't know who was leading this, but made the magic of keeping the acronym and just changing the meaning. I love it. I think now I'm a big fan of it. I'm a trainer. I talk about it. I sell it. You know, this part of my. So I think the use case. It's very important to define. You know what to do and where to go. And finally, just to finish this before bringing Dan back is. Karma, right? Karma is not about the true karma. I have to take my hats off to the people from Shell that comes up with those beautiful acronyms. The karma stands for Corrosion Advanced Risk Modeling and Analytics. So it has nothing to do with the karma itself. So all those acronyms. We have a handbook in IMS that I have a list of 1,000 description to make sure that everybody understand those acronyms. Yeah, thank you, Pepe. Great insight. So then, what's the significance or takeaway for these projects?
Well, I think firstly, Pepe, great descriptions, and I think it's been a fantastic collaboration. So thank you so much for all the support on the journey. I think what I would also say is it's a great example of what I was talking about earlier on. Working together, bringing the best of different organizations together, some of our leading edge research together with your ability to embed that into software and then take it to scale, right, as part of a production solution. That's, I think, what we were talking about with the Open AI Energy Initiative and what we're trying to do. So, kudos to you guys for all the support that you've given us on this journey. I think, I will also say we're just getting started in terms of the end game. One of the things that we see is that more and more, just as you see it happening on your phone, you're going to have these assistants, which are going to be AI-powered assistants, which are going to help you to do your job based on effectively all available data. And you can see that, as I said, you saw it with Siri and with Alexa. The next level of that is now coming in with the co-pilots, of course, and those things being embedded into some of the Microsoft applications already. And we're going to see the same thing in heavy industrial applications. It's not as easy. Data is more sparse. You need more different types of models, but we can see that that's where we're going. And we've talked about the concept of a virtual corrosion engineer. In other words, somebody who is alongside you as your quote unquote co-pilot, who can work with you to provide you additional insights to help you make decisions. And as I said to you yesterday, as we were talking about this, I prefer the term augmented intelligence versus artificial intelligence. For me, this is going to make people more productive. It's going to enable them to do things we didn't think possible, and it's going to drive better outcomes. I think I'm actually very positive and very buoyant about these sorts of changes, and I think it's a positive thing for many people that previously have spent a lot of time dealing with scrubbing and managing very, very messy data sets. But what does that look like in this space? Well, we already talked about the air and Karma and NLP coming together. That's going to happen more and more. And the next part of that that's going to come in is physics-based models. So what we see is the need to bring together the combination of AI-based models, data-driven models, along with textual information and physics-based models, which provide you with the maximum insight into what's happening in your facility in real time, based on real-time data with prediction, and then getting to the point where all of that information is available to help make better decisions, because ultimately that's what all of this is all about. So we're not there yet. We've got a ways to go. We're on a journey, but we're making great progress, and you can see how some of those integrations are happening already.
Thank you, Dan. I got the ladies here pushing me for the as a timekeeper. This is live. Sometimes we talk a little bit more than planned. So let's move to the future of AI, right? So where are we going to? Let's Pepe, can you describe briefly the what do you see as the future of AI, and specifically of the Cenosco AI initiative?
Yeah, so we also have a nice acronym, Luis. So we call something CEN AI or Cenosco AI initiative. We started with some bright minds at the university here in Pula, in Croatia. And we started the collaboration with them to bring the knowledge or the awareness of artificial intelligence into the company, and to help us to generate some range of ideas so that we can start with some POC. So we already come to quite long list of potential examples, like leak prediction, proposing schedule and task based on data, voice commands to generate reports, and many more. So our plan is now to brainstorm together with the university and to propose the best case or the best AI concept for a POC. So I hope this will come during this year, and we will start our own artificial intelligence project.
Thank you. I think just good a connection there. I think there are two great things that it will help, not on the integrity side, but on the data side, is using AI for data cleaning. There's a lot of legacy data, right? You migrate from one system to another, and then you change the methodology, and then you change these. So you have a lot of dust around smoke, and then I think the AI will help to shape that. And we already seen on our ticketing system, right? So sometimes you open a ticket, there's a long history of exchanges and tests, and there's a summarize button that the AI will summarize what is that ticket about. Then briefly back to you, what do you see the future of AI in the asset integrity? What expect to come? I think we've done a long way, but what's the next? What's coming?
Well, I'm gonna to be efficient on time. I'm gonna pick up one of the questions and link back to one of the things that you were
Nice.
just talking about, which is the AI and data cleaning. Because I think it's worth. Actually, I think that's a really key area and something I get very excited about. I think so often what we look at is the future being around applications. We talked about predictive maintenance, safety, reliability, but I think what we miss is the opportunity of AI to help us just manage data better. And this is a key area of research for us. You talked about the summarize button, but it goes beyond that. If you look at the emergence of generative AI, we start to see things like RAG patterns, for example, retrieval augmented generation, which allows us to use generative AI in context to limit the hallucinations of the models and to provide much more targeted information. Now, if you take that to the next level and you say, well, how can I then use that to extract, summarize, and identify key pieces of unstructured information and effectively bring that through as high quality structured data? That is very fundamental, because as you rightly point out, in integrity management, so much of this is logs, is text exchanges, is descriptions. And one of the challenges we have is being able to analyze that systematically. And to do that, we need some form of structured information. And so I think that journey is actually going to be really exciting, because you can see a world where all of that historic data that's currently in a variety of different formats can actually be brought together to provide new insights that we previously haven't seen. And so I think, maybe to link to your actual question, whilst having answered one of the ones that we were going to answer anyway, I think the key point to bring that together is this is going to be fundamental at every part of the data landscape. It's going to be fundamental in the way that we integrate data. It's going to be fundamental in the way that we transform data. It's going to be fundamental in the way we generate data, which is another interesting topic we probably don't have time for today. It's going to be interesting in the way that we drive insights from data. And so almost everything that you can imagine in the current work processes from a data perspective is going to be transformed. The outcomes are the same as we discussed, but that data landscape is going to be transformed, and the way in which we interact with it is also going to be transformed. And I find it very exciting, as you can probably tell. I think it's going to make people's work more rewarding and more fulfilling and more exciting. Yeah, and I think, not saying that there aren't challenges, there are. We can talk about those too, but I think in this space, it's going to have a really profound impact, and I think a profound impact on things like safety and reliability, which I think is really important.
Thank you. It's been great. I mean, we're gonna. I would like to extend a few more minutes to come to wrap up as a conclusion. I would like to pick I don't know, at least one question for each. We had a record number of questions, but Pepe, last words, not the full paragraph. Last few words to conclude to close the webinar.
Yeah, I think what we mentioned during this webinar many times is about the data. And if we talk about the future, I think this data will just grow, especially because of the introducing the sensors of basically everything and anything on an asset. And because of that, so some processes will definitely change, because some kind of inspection will stop be needed, and we will use more and more artificial intelligence to help our inspectors. So I don't think that we will get rid of inspectors, as you said before. Even something that my professor long time said, that digitization is not reducing the need for people, but it just needs different type of manpower. So this is in short my conclusion.
Thank you. Dan.
Yeah, I think from my perspective, I think we're really standing at the edge of something which is going to transform every part of work as we know it. I think that's true in this space. It's true more broadly. There's a lot to think about. I think a lot of it is how you get outcomes from the technology, and I want to go back to that because it's so fundamental. But at the same time, I think the technology is challenging paradigms, and I think the final thing I'd say is we're going to have to embrace it together. It's not about one company. It's not about one individual. It's about working in teams, in new constructs, in new ecosystems, and working in a much more radically open way than we have before. I think that's going to be required of us because of regulation. But I think it's also a necessity, because actually to get the benefit out of this and to achieve some of the outcomes we're looking to achieve, we're going to have to work in new ways. But it's exciting, and I thank you for being a part of it.
Thank you, Dan. Yeah, from wrap up on my side, I think as I don't think inspectors and the maintenance engineers will disappear, right? So they will stay there. For me, the industry is evolving in a way that the new assets will come in a way that is much more prepared to use artificial intelligence. So they will come up with embedded sensors, for example, right? They will take measurements in real time and will start collecting, like you see already in the wind farms. Those turbines already come really loaded with sensors that comes. They predict automatically some of the maintenance and some of these failures. Thank you, guys. Let's extend. Let's bring one question for each, and then we close. I think this is one of the first questions we got from the audience from the registration. That often people say, what is a correlation versus AI? So the question was, the audience said, I'm interested in true AI, not just pattern recognition. which will play the bigger role in asset integrity. So Dan, I mean, can you give us a few words on how you see that pure correlation of data with the true AI?
Yeah, look, I think it's a journey, right? I think if you look at the overall way in which AI has developed, a lot of it initially was pattern recognition, pattern detection, and there's nothing wrong with that. Predictive maintenance, that's what it's all about. When's it going to go wrong? Let's look at historical patterns and identify that. And those solutions have been very effective in driving change. I think at the same time, we are you can argue this either way, right? You can say AI is just prediction, and that's true. Um, but you can also see that prediction becomes very powerful, particularly when it can do things like predict what a sentence might be in a particular style. And so I think what I'm trying to say is, to some extent, that's true. I think at the moment that's where we are. I still think that's where we are with generative AI. I think the next level, though, where we're going to get beyond that is some of the work that we're starting to do in what we call scientific machine learning. So if you look at what's happening at the moment, things like physics-inspired neural nets and FNOs, you start to see these things emerging, which are starting to challenge the paradigm that AI is just about pattern recognition and starting to infuse physics-based concepts into the models. And I think that is really going to change a lot of things. We've seen, for example, in our own research, and we've published papers on this, massive speed up of simulations for highly complex assets. Now, you can imagine the implications if you can get 1,000x speed up on a multi-scale model for a major facility. That's a game changer. Now, we're not there. To be clear, it's still on the journey, but you can see how this development is happening. So yes, it started with pattern recognition. Yes, there are lots of valuable use cases. Yes, generative AI is taking that to the next level. It's making it feel almost human. And the next level beyond that, where you start to bring together scientific knowledge and AI, I think is going to be a true game changer.
Yeah. Thank you. The ladies are pushing me, as always, to close it up. But I have a question for Pepe. Yeah, I think you might guess who they came from, but he came from the registration. So how will AI help Cenosco test IMS and provide testing reports? How AI is being used in IMS to reduce bugs? Yeah, I mean, there's no software that is bug free. Pepe, back to you.
You already mentioned that there is also AI in the ticketing system that we are using Utrecht. So we can summarize when there is a thread, very long thread around some subject. We already start using this summarize functionality, which is pretty cool, and can really bring all the important parts from the thread. So this is from the outside tool, but also for testing or for checking our codes is used the AI. So to get where we are weak or where we use the wrong patterns. So we are also checking our source code with artificial intelligence, and we are also considering. And this is one of the use cases which I didn't mention before, but that we are discussing with the university is on how the artificial intelligence can help us with the testing. So this is also one part, and also with writing the code. So this is also something that we are testing with the university. So it's not only the use cases for IMS, it's also the use cases for ourselves to improve or to speed up our work. Of course, there is also ChatGPT, which can be used, and sometimes is used from the developers. That kind of artificial intelligence or results from ChatGPT cannot be used really as a base of the development, but it helps developers in speed up or come to some ideas. So artificial intelligence is all around us, and it is used in Cenosco as well.
Thank you, Pepe. Thank you, Dan. I could continue easily for another hour here, but we need to close. Thank you guys. I really appreciate Dan, Pepe, and the girls for helping us out. The next Cenosco Live is going to come in April. Yeah. So I think the topic will be announced, but see you there. Thank you guys. Thank you, Dan, Pepe.
Thanks. Bye bye.
Thanks very much.
Thank you. Bye.